Hey everybody, welcome back to our newest lesson in our data structures and algorithms course. Today we're going to be talking about arrays. We're going to look at how they're stored in the memory, how to create them in Java, how to access and use them, and then we'll look at how to use arrays to create newer and better data structures. So let's start by looking at the syntax for how you create an array. I'm using the BlueJ IDE, which uses this nice interactive shell here so we can do some exploration. So I have an int will be the type of array I'm making, and then we put the square brackets after the variable name so that we indicate that it's an array. And I'll just call it array. And there's lots of different ways you can do this syntactically. I prefer to go ahead and use the new operator because we use the new operator anytime we are creating objects or reference types, and an array is a reference type. So I then put int again, and I put my square bracket, and I have to tell Java the size of the array that I want made. Let's start with an array of size 5. Now, once you create this, and because it's a reference type, I can pull it over to my little workbench here. And once you create it, the size is permanent. I cannot change the size of that array. And that's because of how they're made and what exactly they are. So let's take a second and look at how an array is made and talk just briefly about that. All right, so when I say to Java to make a new array, we discussed that you have to give it a size. And so that's what I've done right here. I've given the size of 5. And it's a reference type. We need to understand the difference between reference and primitives. Reference types are called objects. So the array variable name, what I have assigned here is a reference to a specific place somewhere in the memory. Okay, so this is our memory, and we can think of our memory as, well, like a larger array. So we are referencing a specific place in the memory, and the memory has adjacent cells, so to speak, that can be used. And that's why we have to say, array, you make me an array of size 5, because that's what we're going to block off. This variable name array points to this one block here, and the 5 says how many over I can make it, so to speak. That's basically how it works. Now, in order to section off this array, we have to store in a value. So we're going to be storing in values that are default values. And the default value for integer number types is 0. They would be 32-bit, so it would actually be 32 binary 0 digits. But essentially, that's how that works, okay? So now let's go back to the BlueJ and take a look at the array that I pulled over to our workbench, and you can see that it has the 5 zeros that we discussed. There's also a variable called length, and that's kind of a unique feature in Java that we have that length variable. It's very handy. Okay, let's go ahead and start making changes to our array. To store a value, or in other words, to write over a value that's in your array, since we've got to have something there already, we simply need to tell Java what specific cell I want to write in. So if I want to say change this 0 right here, let's change it to a, how about a, let's make it a 3. No, I don't want to make it a 3. That's the location that it is. Let's make it a 17. Okay, so I'm gonna tell Java to write over what's there by using the assignment operator. So you can see that this is 0, 1, 2. So I'm gonna say array bracket 2, and I'm gonna make it a 17. All right, now that should happen instantly here, because changes made to an array are made immediately, because they're reference types. More on that later. So you can see here that this second cell here has now got a 17 in it, just as we'd expect. All right, I can also assign in some other values. The first one would be 0, so let's try that one. I'll make it a 5. Oh, didn't spell it right. All right, and there we go. We can also access those specific values by simply putting the item that we want behind it. And you'll see that it tells me here in my little interactive shell that there's a 5 written there. Okay? And that's pretty much it for arrays of primitives. So just by review, when you make an array, it carves it out with some default values. You can also specify those using what's called an initializer list. We access elements in the array by putting the variable name and then putting what you want inside there. So if you want the first value, it's actually a 0. And you can either just access it like that or use the assignment operator to change it like we just did. We changed it, and I think we put in a 3 on that one. And it just writes over it with a 3. Now, if I want to change the size of this array, I'd have to do something very different. I'd have to make a brand new array. I can't do it. That size is fixed. I don't have to use all of the array. I can leave these default values, but I am stuck with that size. Notice that the array values that I want on there are written directly in these locations. I want to make that very clear here. You can see that these numbers are written directly right there. You know, as soon as I change it, I guess that array 0 was a 5. All right, let's change that 1. Let's make it a negative 7, okay? You can see that negative 7 is written directly there. That is not the case with object types. So let's make an object and store it in the array. All right, so now we've got just a simple little class here so that we can use this and explore what exactly is happening. All right, let me increase my font back again so you can see what I'm writing down here. All right, so let's go ahead and make an array of reference types or of objects. So I'm going to make a bird array. And I think just 4 would be fine. Okay. And I'm going to bring it over to my workbench here on the side by just putting its name. And I'll give it the same name over there. It's fine. Here we are, birds. Okay, we have a little bit different situation here. The array is not filled with zeros because it's not an integer type. You can see that the initial values are null. Null just simply means that you have the object null. It's just empty. It is the default object value. There's nothing I can do with null. I can't get its name. I can't get its age or mass or anything like that because they're null. They're empty. All right, so let's go ahead and let's add some birds to this. So I'm going to say birds bracket 0. That's a good place to start. Let's create a new bird. Recall that our bird took an age. I'll say 5, a name, and I have a parrot named Messi. You probably hear him squawking in the background occasionally. Yep, named after the great soccer player, and he's a pretty light bird, but I don't really know. I'll just type in some random decimal value there. Okay. All right, let's take a look and see what happens. How does it? Wow. Notice it doesn't say like my bird here because it's not a number. It's not a primitive. So this primitive value is not written. Primitive values are written directly onto that section of my array. But when I have an array of reference types, I don't write the object there. I write a reference. And you can see that little reference, that little pointer arrow is indicating that it's a reference to this bird that I've created. And you can see that I have that there. And in fact, believe it or not, the string is also an object, and so you can see that it has, they go ahead and show the name, but in fact, that string name is actually an array of chars or characters. Okay, so just remember that when you make an array of reference types, that you don't write the object directly in that spot. You write a pointer to it. So instead of being like a number 3, so my word array here was pointing to it. When I make an array of bird types, when I make this array and I called it birds, the variable name birds is a reference, it's like a pointer, as they used to call them. It's a reference to a specific spot in the memory. When I give it a size, and I want to say we gave it a size of 4 this time, so I don't need that anymore. Well, what's initially written here is null. So that's what's written there, null. Just an empty object. But the real interesting part occurs when I try and make a bird and write it there, that instead of trying to fit that bird in that tiny little area there, all we fit in that area is yet another pointer that points somewhere else where my actual bird information is, and what's called the object heap. So when you have an array of reference types, you actually have an array of different references. When you have an array of primitives, you have an array of those actual primitive values written right there on the array. All right, and so that's kind of my quick review or / introduction to arrays. We reviewed how to access them, how they're written, how they're made. So in this next video coming up, we're going to learn how to create different new data structures. We're going to begin to look at making data structures using arrays.